So let's see how we can actually do that. So let me share my screen and say how I'm going to do this. Okay. So let me do a favor. So now let's understand how now let's see how we can create this. Okay. Let me share my screen and show you how we can, how exactly Python variables differ. So imagine we are going to create a variable. Okay. So let's imagine that we are, no, even before that, let's see the basic difference between the variables in Python and others. Okay. Now variables, suppose we take the variables in C. And let's take another variable in imagine we are going to take couple of integer variables, right? So if I take an integer variable in C, first what I would like to say is that I have to declare it that I'm going to take an integer A, right? Then I'm going to even assign some value a equals 1. Now, under the hood, how does it store? Do you have any idea? It actually stores something like it first creates a memory block. A memory block gets created by the system with address value something like 0 cross 1 F F E F, right? Or 1 F F F F. Okay. So what happens in the back end is that it actually creates the memory suitable for integer in and stores the value 1 under it. So in reality, a the variable which is in which we are trying to declare here, and when we assign the value 1 over here under the hood, happens like this is going to point to a memory location where the value 1 is being stored. So, and actually a is just going to hold the memory location, nothing else. Now imagine if you are going to have something like tomorrow, I will say a will not have 1 but a will have 2. What will happen? Under the hood, A is still holding the same memory location because ultimately variables just hold a memory location, but in the under the hood, this 1 value will be changed to 2 by the system. So in the same memory location, now 1 has become 2, and now it is no more 1, it is just 2. Now, this is all the things up till 1. But tomorrow, if someone comes and says, no, 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 I would like to have another variable called b, which also I would like to assign to 2, you know what will happen? Under the hood, system again creates a new memory block for b. So if we consider this as memory 2, 0 cross 1 F E F. Okay, another memory block, and stores the value 2 underneath. Meaning B is again pointing to the new memory block, not to the actual value per se. Now you might be wondering, why am I saying all these things, correct? I'll tell you in a bit why I say all these things. But before that, let me complete this. Now tomorrow you say I would like to increment the b value and I would like to make it 3 for some of my logic, then how does it work? It still is the same memory location because b points to the same memory location, while the value is just updated instead of 2, 2, 3. So here at any point of time, a value will have value 2 while b will have the value 3. Now let's analogically compare with Python, because Python has become quite a popular programming language of late, particularly for data analytics purposes. And let's see why it is considered to be most popular programming language for data analytics. And also, I would like to give a stark contrast with Python and other programming languages like C or C++, C Sharp, Java, or take any other language. Now, let's create a variable, and creation of variable in Python is absolutely easy. It is A equals 1. You don't need to explicitly declare what type of data type you're going to store in that variable, because Python is intelligent enough to inference the type code from the value which you assign. What I mean by say is that under the hood, it actually creates something called as Py object. So it creates a Py object and using see Python. So what happens is that whatever variables which you create in Python is actually not a variable, but it's actually an instance of a Py object. What do you mean by that? What I mean by that is Py object is the one which actually creates a memory over here, and it also stores two important, or in fact three important things, but out of that two are very important. Those are, one is a type code. What do you mean by type code? Type code, I mean to say, is that it actually stores it as integer over here, because system infers that it is an integer, it is storing in A. Now, imagine we'll have an, okay, let's complete this and then go with the next one. So it also stores number one in the same Py object instance, because we have assigned one to it. Till here, this analogically looks similar to the other programming languages like C or C Sharp, Java, or anything else. However, there is a stark contrast once it comes to the next one, because since this is an object, how will the instance variable A of Py object understand that it is being referred by Python? It doesn't know, right? So there is an attribute called reference counter, which actually tracks the number of instances this Py object is referred to. Means now it has value 1, means only one Py object instance is being referred at this stage. Okay. And I'll let you know in a while why I mean to say and what is the importance of this reference counter soon. Imagine if you're going to tomorrow change the value A equals 2, what will happen? A in Python is a instance for Py object. This is what I said just now, right? So it's not a memory location which is directly being referred to, unlike any other languages like C, C Sharp, or anything else. In C, C Sharp, so this would have been a memory location, correct? But here it's a Py object. So under the hood, it happens something like create some new Py object. We can name it like Py object 2, and it again infers the data type, the type code, and then the value. And the most important part is this reference count. Here it refers to 1, meaning now it has this Py object instance is being referred, and hence it is a reference count is 1. Now you might ask me the question, what happens to the previous one, right? So the previous Py object instance at this stage will change from reference counter 1 to 0. Because this new Py object instance A refers to a new Py object instance, and hence the reference count is 1 here, while the older one is now will not reference anymore. Hence, it is changing back to 0. Now you may ask me, Arun, how does this work, or will it not impact any performance or anything? Let me tell you that in a bit. Under the hood, what happens is that PyObject instances which are having a reference count is 0 will be used for garbage collection purposes. I mean, the system periodically checks for all the PyObject instances with the reference counter equal to 0 and tries to put them into something called as trash can. Meaning this is not going to be used anymore in future. Right? So this is one important concept, and I'm going to come soon why I say this is very important. Now let's move further. Tomorrow we'll say that we'll have another variable called b, which is referring to 2. Then what happens? Since Python references to the object, PyObject, and not to the memory location in itself, this b can take the same PyObject instance and doesn't need to create a new PyObject instance, because system tries to reference the data type or type code from the assignment, and the value also it knows that it's the same thing. Then why don't I reference to the existing PyObject instance rather than creating new one? Right? So at this stage, what happens with the reference count? Now the reference count will become 2, because now 2 PyObject instances, also called variables, are being referred to the same of PyObject. So imagine tomorrow this b will become 3, then what will happen? At this stage, the system will try to create a new PyObject instance with PyObject 3 with again an integer and value 3 and a reference counter will become 1, because this is object referred to 3 value. Only one object is there as of now. So this b will refer to this, while it will no longer refer to 2 anymore. Okay. However, then what will happen if this b doesn't refer to that anymore? Then what will happen? Actually, to the counter. Counter will automatically decrement and will become 1 over here. So now the PyObject instance 2 will have a reference counter 1, while the PyObject instance for the b, that is PyObject instance 3, will also have a reference counter 1, meaning this is being referred by one variable and the other one is being referred by the other variable. Now you may ask me, Arun, what is the advantage of doing all these things? Where is it useful? Correct? Let me tell you this point in a bit. And this is quite an interesting and most important point of all. Imagine you are going to create a program which will loop from value a, 1, 2, all the way till 100. Okay, you have a looping logic which loops from all the values 1, 2, 3, all the values till 100. Then what will happen? In this case, it is just a matter of creating one memory block and incrementing the value in each of the scenarios from 1 to 2 to 3, all the way till 100. So one memory block can serve the purpose for this. Because A ultimately will refer to the memory block, and the memory block values have been changed. That's it. Right? Now let's contrast this with Python. Here also we'll say that the values vary from 1, 2, 3, all the way to 100. Then what will happen? So in this scenario, the interpreter creates a PyObject instance for each of the iteration. 1, 2, 3, all the way till 99, 100. And every time when the value increments 1 to 2, this reference count will become 0, 0, and is 0, this 0, 0, all the way till 99, it will become 0, while the 100th value will become 1. The reference counter will be 1 only. That means the garbage collector needs to clear all the previous 99 values before it attempts to complete the program. And this adds on to the performance. And for this exact reason, we have something called as Python libraries, which helps us to improvise the processing part. We have NumPy, we have Python, we have PyP, we have many other libraries that helps us in improvising the execution. All these things help us in improving the execution part. Not to just mention that, we can even employ something like advanced hardware, could be GPUs, additional GPUs, and others, which ultimately help us in increasing the speed of a program. Now, you may ask me, Arun, is the same case with the C or any other language also? You can add advanced hardware over here, like GPU or anything, and again, this will also increase the performance. Absolutely right. However, given a scenario like machine learning or any data science problem, it is what we need to know over there is that we have quite a lot of extensive libraries in Python, and we may not have those many libraries in C or any other languages. And this is the place where Python scores over other programming languages, because Python is first of all open source. Okay, it's a general purpose programming language. It is so versatile, cross-platform, and many other advantages typical Python program has when compared to all others. Yes, some of them are also available in other programming languages like C, C++, Java, .NET, and others. However, there are not those many scientific processing libraries or data science or machine learning libraries that are present in Python when compared to other programming languages, except some of the languages like R, Scala, and others. So Python being it's a very language, you can almost treat it as an English language, number one, which is so easier to learn, and Python being an open source has an extensive libraries. At the same time, these days Python is also being used for many other applications like IoT using something called as Raspberry Pi. So these are all the advanced topics, but just to give you background, why is Python being considered compared to any other language like C, C++, Java, .NET, or anything else? Is because of the libraries present in Python. And also the ease in which you can create a program in Python when compared to any other programming language. Not to mention, Python can execute in the same way in any type of operating system, be it Linux, Windows, Mac, or anything. And these days, people are also contemplating whether it can be used for mobile operating systems too. And hence, going forward, Python has a huge scope, particularly in data science field, and also it will be a de facto in deep learning and any other complex algorithmic operations. If you have any doubts, I'm now really happy to take them because I'm almost done with my session. I hope the session was useful, and if you can just write your comments in the below video, that helps me to understand how did the session go and what I can improve in my next sessions. Thank you.